Welcome back. Today we're going to practice identifying the different types of chemical reactions, and we're also going to balance them. So I will make one deliberate mistake. Can you spot it? All right, so the first chemical reaction that we have, the equation is NH3 plus I2, that's iodine, gives us N2I6 H2. So let's start by identifying the different type of atoms, right? We have nitrogen and iodine. So if we look, we're going to, and hydrogen. So we're going to start with the iodine. So you can see on this side, on the right side, that 6 of them right here. So I'm going to do that in we have 6 iodine, so we have to put a 3 over here to make it 6. And now we can focus on the nitrogen. And you can see over here that there's 2 nitrogen on the right side. Therefore, we have to put a 2 here to make it 2. So now the nitrogens are balanced on both sides. However, as we put a 2 on the left side, we've now created not 2 hydrogens, but 2 times 3 hydrogens, which is 6, a total of 6 hydrogens. So now we also have to create 6 hydrogens on the right side. And so 2 times what will give me 6? You guessed it, 2 times 3. And now my equation is balanced. Now, what type of chemical equation is this? We can see that it looks like we start with N combined with H, and then as iodine gas comes along, the N is now bonded to iodine instead of H. Can you remember the name of this type of substitution? That's right, it's called single replacement. So that would be the type. Let's look at the second chemical equation. So we have sulfuric acid, so H2SO4, that we add with NH4, so that's ammonium hydroxide, and then we get HOH, which is the same thing as H2O, really, and NH4SO4 minus. As you can see, this is ammonium sulfate. So here we're going to start very simply with, I guess we can start on what's happening over here. We're going to start with let's start with the hydrogens. Okay, so actually let's start with the nitrates, the ammoniums. Okay, so we can see that this group of NH4, right, there are 2 of them on the right side. And so what we have to do is we also have to create 2 of them on the left side. And that's what we're going to do. So here we have the group of NH4. Therefore, we're going to put 2 over here. So by doing that, we've now created 2 H's and 2 OH's. Okay? And on top of that, we also have an additional H2. Okay? So that's basically 4 H's and 2 O's that we have to have on the right side. So what we're going to do, we have 2 NH4OH. So to create the 2 OH over here, we can put this. This will create 2 of the O's, but it would actually create 2 times 2 of the H's, which is 4. That is okay, because if we look on the right side, we'll see that there's actually not only 2 H's, but there's also an additional 2 H's here. So we actually have 4 of them, so that's okay. So now let's look at the SO4s. We have one on each side, so they balance. And so we are now done. So let's see what type of chemical reaction we have here. We can see that on the left side, hydrogen is with sulfate. So if I do sulfate this way and I have the OH this way, we can see that they have now swapped partners, right? That now the hydrogen, instead of being with the blue, the hydrogen is now with the green. And then the nitrogen, instead of being with the green here, is with the blue. So this type is called a double replacement reaction. Next, we have C2H4 plus O2 gives us CO2 plus H2O. So the first thing we want to do is we want to notice that there is actually an even odd number on the right side, right? We have 2 and then 1. That's a total of 3 oxygen. That's not good. You always want to have an even number if you can. So the first thing we're going to do is going to put a 2 over here, so that now we have 2 oxygen here and 2 oxygen here for a total of 4 oxygens on the right side. So that's good. Now we can proceed with balancing our equations. So notice that we have 2 carbons over here. So we're going to put a 2 over here now, so that we also have 2 carbons. By placing a 2 over here, we've now have created 2 times 2 oxygens, so that's 4, plus the 2 that are here, that's a total of 6, all right? So now we have to create 6 oxygens on the other side. So 2 times what will give us 6? 2 times 3 will give us 6 over here. And now we just have to make sure that the number of hydrogens are on the same, that they match on both sides. We have 4 on the left, which is good because we also have 4 on the right, right? 2 times 2 gives us 4. So now this equation is balanced, and you will see that we have produced carbon dioxide and water. Okay, so because we have oxygen, this is an oxidation reaction. Next, we have copper oxide splits into copper and oxygen. So again, we're going to start with the oxygen over here. We see that we have 2 on the right side. Therefore, we need to put a 2 over here on the left. By doing that, we've also now created 2 coppers. So we have to put a 2 over here. And now both our coppers and both of our oxygens are balanced. Now, do you see how this particular compound splits into 2? Do you remember what is that called? That's right, that's called a decomposition reaction. Next, we have H2 and oxygen to give us water. Okay, so very simple right here. We can start with the O2 on the left side. We see that we have 2 over here, but we do not have 2 on the right side. So simply replace the 2 here. Now we have 2 oxygen, but we've also created 2 times 2 hydrogens, which is 4 hydrogens. And so in order to remedy that, we are going to have to put a 2 over here so that we have 4 hydrogens on both sides. Do you see how they both come together? Do you remember what this type of reaction is called? That's right, it's called a combination reaction, also called a synthesis reaction. So now I'm going to give you a couple minutes to try to identify the mistake, that one deliberate mistake I have made. Can you spot it? pause to try to spot it. That's right. Good job. The mistake was over here. This is not called a oxidation reaction. This is actually called a combustion reaction. Anything that burns in oxygen to produce carbon dioxide and water is called a combustion reaction. Well, thanks for practicing with me. I'll see you in the next one.